Okay, today we're going to talk about section 5.3, locating real zeros of polynomials and the rational zero theorem. Alright, the rational zero theorem. If f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus, and then all your intermediate terms, all the way down to your constant term, a sub 0, is a polynomial with integer coefficients, then any rational zero of f of x must be of the form of plus or minus p over q, where p is a factor of the constant term a sub 0, the last term, constant term, and q is the factor of the leading coefficient a sub n. So remember, this is a generic form of a polynomial, and we're just saying that we take the factors of the last term and factors of the first term, put them over each other, and all the combinations we can get, those are our possible rational zeros. Now you can have irrational numbers, square roots, and imaginary numbers that won't show up in this theorem. So here it wants to list all the potential zeros. So we have our q, so factors of. So I like to do p first. And then I say factors of p are going to equal plus or minus. And then we have 1, so that's going to be 1. And then we have factors of q. Well, q is equal to 4. And that's going to be plus or minus. You have 1 times 4 and 2 times 2. So those are all the factors of 4. So the potential factors zeros, I should say, are plus or minus. This is how I like to do them. I like to say p over my factors of q. So I have 1 over 1, I have 1 over 2, I have 1 over 4. So I put 1 over 1, 1 over 2, 1 over 4. And that's my list. Of course, you wouldn't write anything with fractions that are unsimplified, so you'd just, instead of writing this 1 over 1, you'd actually write it as 1, 1/2, and 1/4. And for Hawks, they don't have to be in any order. You just make sure you don't have repeat values, and you make sure your fractions are simplest form. I'll take that list. Next, it's saying identify the actual zeros. If necessary, use polynomial division and other long division or synthetic division and or the quadratic formula. So looking at this, there's a couple things we can do. It's a quadratic, so we can go ahead and use the quadratic formula. Also, it's the difference of two perfect squares. We may factor it that way. You might say, well, this would be easier if I said this is 2x plus 1 times 2x minus 1. All right. And that's fine, but let's say we're going to just guess and use synthetic division as practice. So from this list, since we know it's going to be plus or minus 1/2, we'll pick something that doesn't work. Like, let's say we pick 1. So I'm going to have 1. I'm going to let k equal 1 and see what happens. And so 1 is going to be my potential zero, rational zero, and then I'm going to have 4. Remember, this is my x squared column. This is my x column. This is my constant column. So it's 0 and a minus 1. So if I bring the 4 down, I have 4. 1 times 4 is 4. Add this together, 4. 1 times 4 here would be 4 again. And then I subtract 1, and I'd get 3. And that remainder is not equal to 0, so 1 is not a factor. You try negative 1 next if you wanted to, but I don't think that would work either, due to the fact that it would just change the signs here and I'd still get something that wasn't 0 as my remainder. So let's try. So that didn't work. This is where it's really good if you have pencil. So this one didn't work. Let's try something else. Let's try 1/2 now. So we try 1/2. So k is equal to 1/2 now. And then we're going to draw our synthetic division bar. We're going to have 4, 0, and 1. This is our x squared column, our x column, and our constant column. So we bring down the 4. So 1/2 times 4 is going to be 1/2 times 4 is, it's going to give me 2, and then 1/2, and then we add these together, we get 2. 1/2 times 2 is 1, and we get, oh, it's supposed to be negative 1, excuse me. I knew I was missing something. The negative 1 right here. And so we'd get 0 back out. So that works. So we got one of our, so we have one factor is going to be x. Remember, it's x minus k. So x minus k would mean that this would be x minus a half times what we'll have left. Remember, this becomes our x column. This becomes our constant column. And so, bad notation, column or constant column. So that means what we'd have left would be 4x plus 2. And you're thinking, that doesn't look like this, but actually we factor a 2 out of this right here. And we'd say this is x minus 1/2, and then they would say 2 times x, 2x plus 1. Well, if we move this 2 to this one, this factor right here, so we don't get a fraction, we get 2x minus 1 and 2x plus 1. So this is factored. You know, I have this factored, except if you can avoid, if you have a common factor, you bring that out. You know, if you can factor a greatest common factor out, you do that. And if you do that and you give it to here with the one with the fraction, then you get all integer coefficients. So that looks nicer. But any one of these would be correct, technically correct, although Hawks would probably be looking for this answer right here or this one right here. This one, it might notice that you have a greatest common factor you didn't bring out, so it might count that off. You'll have to practice and find out which one works the best. I'd say it every year, and then one year they'll change it, and so students will say that I'm wrong. But like, it's definitely this way, and then they'll change it. So always do practice to notice what kind of how they want their answers. So next we want to list all the potential zeros again. Once again, I like to do p over q, so I say list the factors of p first. Of p, and p is equal to -3 this time. So that's going to give you 1 and 3. Remember, it's plus or minus out front. So 1 and 3 are the only factors of p. And you're going to have factors of q. -6 plus or minus are going to be 1 and 6, and then 2 and 3. So potential factors, or potential zeros, I should say. And that's going to be p over q. And it's going to be plus or minus. And how I like to write it once again is have p. And since I've already written it with my p's over my q's, it's easier just to glance up and remember p over q. And so we're going to have 1 over 1, 1 over 2, 1 over 3, and 1 over 6. Next, we're going to have 3 over 1, 3 over 2, 3 over 3, and 3 over 6. So that's my list, but we have repeats in here. So this 1 over 1, we could rewrite that as 1. This 1 over 3, we could write that as 3. And this 3 over 3 would be written as 1. And this 3 over 6 would be written as 1/2. So actually, if we're going to do our list should be plus or minus. And Hawks will have the plus or minus, and they should have the curly braces there for you as well. 1, 1/2, 1/3, 1/6, and then 3, and then 3/2. And then we already have 1, so we don't need that 1. And then we already have a 1/2, so we don't need that 1/2, so we're done here. So that's a list of all our possible zeros. So now once again we're going to use synthetic division, so make some guesses, see how this is going to work. Now I'm looking at this and I see that, you know, my signs are negative and positive, so chances are positive numbers will work, negative numbers might work. And if we're looking at this, if we have something big like a 3, and we have 3 times 6 as our first one, we're probably going to get something like positive 18 if it's negative, and then that'll give us something close to maybe a little bit past 20. That might be too big. Maybe something like 2 will work. Let's try 2. 2's, no, we don't have 2, excuse me. Let's try 3 then. Let's try -3. So I'm going to say k is equal to -3. So we have -3, and we're going to have our -6, our -11, our 20, and our negative 3. And so we have all our powers of x represented here. So I bring this down, so this becomes negative 6. I multiply these together, it becomes positive 18. Add these together, and that's going to be what? 7, and then negative 3 and 7 is going to be negative 21. That'll be negative 1. 3 and negative 1 is going to give me positive 3 with 0. So I made a good guess because I noticed, 6 times 3 would give me 18. That would give me 7. That's 20. That's close. You can do some mental arithmetic to make good guesses. If you make wrong guesses, you just start over. Like if you guessed 1 and 1 didn't work. If you guessed, maybe a half didn't work. Things of that nature. But here, so now I know that x plus 3 is a factor. So this is a 0. This is a 0. Means this is a factor. Now, what we have here is we're going to have negative 6x squared plus 7x minus 1. And what we could do here is we could do synthetic division again. But since it's quadratic, we might as well just try to factor this real quick. And in factoring this, is there a way I can get factors of 6 and factors of 1 to add to give me 7? So let's think about that. So if I had negative 6x times x, and then if I multiply that negative 6 times negative 1, that would give me positive 6, and this would give me positive x, so that would be positive 6x, positive 1 would give me positive 7 there. So that's one way it can factor. So here we have our factors going to be, so this is going to give me, our zeros are going to be negative 6x plus 1 equals 0. So that means 1 equals 6x, which means 1/6 equals x. I just move the 6x to the other side so it's positive. Or we have x minus 1 equals 0, so x equals 1. So our other factors are going to be 1/6, or zeros, are going to be 1/6 and 1, along with the negative 3 we found before. And so if we were to factor this completely, we need the x plus 3 here as well. So we factored it completely. These are the factors, all right, here, and these are the zeros. So if it asks for the zeros, this is what they want. If it asks for the factors, this is what they want. If it asks for the factors, it wants x plus 3 times negative 6x plus 1 times x minus 1. The 0 is 1/6, 1 and negative 3. So once again, you can make some good guesses and hit it on the first try. You can miss some others. But if we look back at this list, we notice we had 1/6 in our list. It's a rational number. We also had positive 1 in our list. We also had negative 3, which is what we guessed here, the negative 3. So all our rational zeros were in our list of possible zeros. Like I said, this is really, really awesome, because if you have to do this by hand, if you have to factor these things by hand, I mean, what are you going to start with for your synthetic division? I mean, an infinite number of choices is more choices than you want to comb through. So this narrows it down from an infinite number you could have looked at to, for your rational zeros at least, to a finite number, And if these numbers are relatively small, these possible zeros are small, occasionally what will happen in a Hawks is you'll get something like 12 here and 8 here, and you'll have a bunch of factors. But always make sure that you can't factor something out front first to make your life easier. Once again, we're going to have the factors of p. Oops, I said p and then I wrote q. So the factors of p, p is going to equal 3 again, or negative 3 again, and that's going to be plus or minus. We're going to have 1 and 3. And the factors of q is going to be plus or minus, and then we're going to have 1 and 2. And so we have relatively few, so potential rational zeros. Oops. I looked away at the screen and lost track of where I was. So the potential rational zeros are p over q, and that's going to give me plus or minus, and we're going to have 1 over 1, 1 over 2, 3 over 1, and 3 over 2. And once again, we wouldn't write this. This would be written as 1. This would be written as just 3. So to rewrite this list to make sure that we got it right when we plugged it into Hawks. Like I said, it can be written in any order. That's just typically what we have there. So our possible zeros are 1, 1/2, 3, and 3/2. So it's kind of nice. Now this one's a little bit different. Before we did a quadratic, which we could have done by hand, by factoring or the quadratic formula. Cubic, there's no way we have a formula for that. There is a formula. It's nothing we'd use though. Not on a daily basis. So we just go through our synthetic division at least once to get it down to a quadratic, and we can use the quadratic formula or factoring to solve. This one right here though, there's 4, or as to the 4th power, so we're going to have to do synthetic division twice to get it down to a manageable form. So I always start with my whole numbers like 1 or -1 or 3 just because they're easy to do, and 1's a really good choice here, and I'll tell you why. If you ever notice that you have a bunch of numbers and they have add up, so I have 3 and 7 and 1 as my coefficients, that adds to 10, and -7 and -3 add to -10. So I have +10 and -10. Chances are 1 or -1 might be a 0. So if you have like this symmetry going on, you might have 1 being a 0 if you notice you have, especially if your coefficients stay relatively symmetric. You know, they may have big terms and small and whatever. They add or subtract out. And just something you can look ahead to do patterns. Like I said, in math, we try to give you nice problems, so it means we kind of limit ourselves in the coefficients we can use and the number sizes we can use. So there are usually patterns you can see to help you with your homework. In general math, it may not work, may not be too helpful, but in homework, there are patterns. So 1 times 2 will give us, so what does 1 times 2 give us? That's 2, and then we get 9, and 1 times 2 is 9. It's going to give us 10. 1 times 10 is 10. It's going to give us 3, and 1 times 3 is +3, and so it's going to give us 0. So we have the following. Now here's the interesting part. So we've done the quadratic formula, or I'm sorry, we've done the synthetic division once. Now the neat thing about synthetic division bars, it's written in such a way that you can pick up. If you were successful the first time through with a remainder of 0, you just pick up right where you left off and do it again. Now notice my P's and my Q's didn't change. Right, so my list of potential factors are still the same: 1, -1/2, 3, and 3/2. What did I say? -1/2. 1/2, 1/2, 3, and 3/2 are all possible zeros still, because I still have 2 and I still have 3 as my 0. But if these numbers changes, it may make this list smaller. So watch for that. So if we want to do it again, we can do it, and we can say here it looks like I have 2 and 9. So 2 and 10 gives me 12. That gives me 12. I'm going to try -1 and see what that gives me. So let's try -1 this time. 1 could have been it again. I don't think it is because we don't have any negatives in this right here. So I bring down the 2, and I'm going to have -1 times 2. It's going to give me -2. It's going to give me 7. -1, that's going to give me -7. And then that's going to give me +3. And that's going to give me -3. And that's going to give me a remainder of 0. So once again, I made good choices. If it doesn't work out, you know, you can start over. Erasers are great for this, using erasers. So now I get this polynomial at the end. So let's write here. This gave me my x plus or -1 factor. This part gave me my x plus 1 factor. And then down here, I'm going to have the polynomial 2x squared plus 7x plus 3, because I reduced the powers by, this was an x to the 4th, then it became an x to the 3rd column, then it became an x squared column, because I reduced the powers 1 each time I did synthetic division. So now I need to find factors, or I need to find a way to multiply 2 and 3 together to give me a middle term of 7. And I don't think there's a good way of doing that. I'm trying to think off the top of my head if I can do that. Should have looked ahead to my notes. I didn't do that before I started. So looking at this, yeah, we can do it. If we have 2x and times 3 will give me 6x, and then 1 plus 1 and x here. So that'll give me, so I can factor this now. So I now have the factors. I have my x minus 1 and my x plus 1. I'm running out of page as usual. And so that corresponding 0, so this gives me an x equals a 1 and x equals negative 1, and then this 0 right here, so we have x plus 1 equals 0. That'll give us 2x equals negative 1, so x equals negative 1/2. So I get negative 1/2 as well. And then this other one is just going to give me negative 3. So these are my zeros. These are my factors. All right, so that's factor that completely. And once again, we can go back and we can look. This list of factors right here, they were all in my list of potential zeros. 1 or negative 1, negative 1/2, and negative 3. Yep. And that is it for today. There's many more you can do. Note in your homework, you could get one here where you may have like a cubic or quartic that has a quadratic with 2 imaginary numbers, zeros. So when you go to factor it, you may have a list of zeros and only one of them work because the other zeros are imaginary or irrational, and if that can happen, finding this list can be very hard or just not very easy. But once again, try going through the whole numbers first, like the 1 and the 3, positive 1, negative 1, positive 3, negative 3, before you get to the fractions. And then if you run out of factors, you probably made a mistake somewhere because they wouldn't give you one in the section that didn't have a rational 0. But you could get a quadratic. You could get down to this form right here, and this have imaginary zeros or irrational zeros. Irrational meaning you have a square root. If you could get something down like, you could get down to the point where you have something like this, where you have x squared, x plus 17. And then right here, this would be imaginary. I'm pretty sure that's imaginary. I want to say it is. And this will be imaginary. And so you'll have to use your quadratic formula and say negative b, or in this case plus 1, plus or minus 1 squared, or negative 1 squared, minus 4 times a times c, which is 17, all over 2a. So you get 1. This is just another example. This is not a continuation. This is example like 4.0 or something. And so you get plus or minus, and you get the square root of 4 times 17. 4 times 16 is 64 plus 4, which would be 68. So that would be 1 minus 68, which will be 67. And that will be over 2. And I don't think 67 has any whole number factors. Sorry, perfect squares you can bring out. So, and this is actually negative 67, so actually it'd be minus, or plus, actually, 1 plus or minus, oops, I'm going off the screen, I square root of 67 all over 2. So you may have something like, oh, your zeros are going to be, x could be equal to 3, x could be equal to 1 plus or minus, or actually you write plus, I square root of 67. Did I say 63? 67. And then we have 1 minus I. So you could get the situation where you've generated imaginary zeros, or imaginary zeros have been generated. So you'll go through the whole process and only find one rational zero, and the other ones are irrational or imaginary numbers. So be aware of that could happen as well. All right, that's it for today, and I hope you all have a great day.